Yeah, kid, welcome everybody back to, I can't even say back to, the first episode of the 3D Printed Authority. I'm your host, Charles Weinraub, CEO of Printed Places. A little bit of background what Printed Places is. Printed Places is the first real estate development firm that specializes in 3D printed construction technology. So essentially we utilize SQ4D, the leader in 3D printed construction, in my opinion, in the world, to 3D print houses, commercial properties, medical, industrial. And you're going to see exactly where this goes. 2023 is when we start. We have a 25 lot subdivision in Riverhead. We're going to be printing the largest 3D printed subdivision rental community in the world. We have a 2-story townhouse development going up in Nassau County and a ton of projects slated for after that. So check out the podcast every week for extremely interesting guests like this gentleman right here. It's an absolute honor, Mr. Kevin Paul.
Thank you.
H2M. So for those of you who don't know, H2M is Long Island's largest architectural firm. They've been around how many years?
It's going to be 90 years coming up.
500 plus employees, over 10 offices.
Over 10 offices.
You've been a senior partner over there for the last 7 years. And
kind of, last couple of years.
Oh, okay.
Been there 7 years.
And you, sir, you designed the first legally 3D printed house in the country.
With the help of SQ4D
Yes.
and an amazing engineering team in-house. We actually, met with the team, Kirk and Enzo, and with the town of Riverhead, and put together, prior to the New York State Building Code codifying that particular type of design, we're able to put it together and make sure it worked really, really well, which it did.
So for those of you who haven't seen it, the first legally 3D printed house was in Riverhead. It's a 3-bedroom, 2-bathroom. And we actually 3D printed the forms, footings, foundation, slab on grade foundation, interior and exterior walls, and put a roof truss system on. There's a ton of YouTube videos on it. We'll put the links down in the comments. You could definitely check that out. But before we get into actual 3D printing, I'd like to know just a little bit about your background so people understand what you were doing before, how you got into the 3D printing, and where you see it going in the future.
So briefly, 25 years in private practice, focusing mainly on residential, smaller scale type of things. Came to H2M to manage a Build It Back program after Hurricane Sandy, which continued kind of the same thing, rebuilding, mitigating flood damaged homes across Staten Island, Brooklyn, Queens. So a significant background in looking at what houses could and couldn't withstand. And the idea of the 3D printing, obviously there's been 3D printing around, for a long time, but typically not for construction size projects, right? Yeah. Little things, little studies. And we've used them even in H2M for small model studies, but typically on a very, very small scale. So the idea of being able to print relatively quickly a house that could withstand flood, fire, insects, wind, really exciting to me. So when I heard about it through SQ4D, I got really excited because this seems to be kind of like the answer to all the things I've been dealing with relative to fire and flood since the early 90s.
Yeah, so we were talking offline before, and the construction industry has essentially been the same for 100 plus years.
Thousands, right? You go back and look at the Romans, and it's 2 posts and a piece of something, a piece of stone across the top. I'm simplifying, but basically that's the basic idea.
So yeah, in my opinion, this is the biggest, and would you agree, the biggest construction disruptor in
without
hundreds of years?
Without a doubt.
Like, I try to put it in perspective and relate it to people. I'm like, the world will never ever be the same after this. This is essentially the computer for construction. It's that significant.
Right. Or kind of like the iPhone for construction, because it literally will change the way people view how they live. It'll changes the way they anticipate how construction is going to occur, and then also it will simplify their life moving forward, knowing that what we're building is not a 25 or 30 or 40 year structure. It's going to be a 100-year structure.
Exactly. So with that said, talk a little bit about current construction methods, issues that you have, and then kind of compare them to what you see with 3D printed houses and how things are moving forward in the future.
I'm not sure people are aware, but every 3 years New York State adopts a new series of codes. So every 3 years our codes change. Sometimes they change significantly, sometimes just a little bit. But every time we get a new code issue, it adds complexity to the way we build. Okay.
Why do they do that?
I'm not quite sure, other than certainly it's for the public safety.
Okay.
So let's, I'll try not to be, too sarcastic about it. Certainly it's for the public safety.
Okay.
And that's paramount in what we do, because that's our responsibility as architects and engineers. We're here to protect the public. However, some of the things that they make us do, and you've seen this over your career, we didn't strap houses in 1967. We didn't strap houses in 1997. We started strapping houses in 2003. I've been working in the industry for 35 years. I've built homes that have seen multiple hurricanes, multiple windstorms, multiple floods. They're still there. Okay. So I understand strapping. There's another layer of complexity to the construction progress, and process. So when we're talking about eliminating things like, tie downs, because we have reinforcing going into our poured, printed footings, shear walls that are actually, the walls are already shear walls as they're built. I don't have to worry about nailing patterns and hold downs, and it simplifies a number of different things throughout the process, which speeds up construction, simplifies construction. But doesn't really change the safety or the functionality of the end product. So that's really where certainly we have to address all the code issues, but they're not layers of things put onto the project. They're inherent in how we do it.
Yeah.
It makes a significant difference.
Yeah, I mean, I think people really need to understand just every time I have obviously TikTok, Instagram, tons of videos, millions of views, and people always ask very similar questions. The biggest question, ironically, is how do you hang something on the wall? Which you would never think, but very, very easy for those who are out there. You just go, zip it in. It's not that difficult because the mix has no aggregate.
Mix has no aggregate, and effectively it's, if you live in a home that's, got steel stud construction, it's no different. You don't nail into steel studs, right? Like H studs, you screw but this is really, it's kind of an amazing material because it has a significant amount of strength.
And it's so simple.
Simple, very simple. I think that's what people confuse. It's simple. It's complicated in terms of getting to that simplicity, right? With the amount of equipment and the amount of software required. But the end result is effectively what we're used to seeing. And that's, I think, even with the first house, it was kind of critical that people could recognize it as something familiar in terms of a house.
Yeah. So, I mean, and I have to really give credit to Enzo. I mean, he's a genius, and just the way he put this whole thing together. So other 3D printed companies that are trying to do what he's doing, they use a proprietary blend, which is a lot more expensive and has additives, and you essentially have to buy the mixture from them, where he just has a very simple Portland sand and water mixture, which you can get at any Home Depot, anywhere. I'll segue that into building departments. So for all the, the fanciness, it's essentially a concrete house.
It's a concrete house.
But building departments has never seen this.
Right.
So talk a little bit about the process of you working with Brookhaven, working with Riverhead, getting them to understand and be confident that this house is going to last and there's not going to be any issue out there. Because a lot of people want to be the first, but when it comes to like building in municipalities, they don't want the liability of being the first.
Right.
So talk a little bit about that process.
And so the towns, obviously are concerned about health, safety, and the durability of the material and the structure. So our job is to actually show that it does meet certain code requirements relative to strength, right? Porosity, how it works with reinforcing. So it's just really a series of studies, and SQ4D has provided us with a tremendous amount of information relative to ultimate breaking strength, okay? And what happens to the material as it weathers, what happens to it over time. It's really trying to match up the information that the material produces to what the code requires. And early on, there's a portion of the code. It's a mass wall, which effectively covers things like straw bale homes, okay, or homes made out of reused old tires, or
They have that?
log homes, yes, adobe homes. So it kind of initially falls into that, but it's a concrete home.
Yeah.
And people do believe, even on Long Island, we have houses that were built out of concrete block as far back as the 20s and the 30s. So it's really analogous to that type of construction, except those homes have no reinforcing them. They're basically just plain laid concrete. These walls are always reinforced, and they provide just really crazy opportunity for insulation, for example. So we can get almost an R25 wall in concrete construction, which you can't do with the concrete block. You can't do with a insulated concrete form. So it gives us a lot of opportunity to do some really nice stuff that's going to benefit the homeowner and also meet the code requirements.
So for people that don't really understand, explain a little bit more about R value, why that's important, and ultimately how you end up achieving some crazy R value with 3D printing that you can't with traditional steel.
Right. Every home, every building built in New York State has to meet the energy code requirements as set forth by the state. So houses, typically, if you're living in a wood frame house with 2x4 walls, the best you're going to do is an R15, and that's bad insulation. You might be able to with a spray foam get that up to R, 19 or 20. And basically the insulative quality is, so your house stays cool in the summer, right, and warm in the winter, and performs relative to how building science looks at houses. And that's a whole other podcast in terms of how houses perform in a climate like ours, which is really cold in the winter and really hot and wet in the summer. But we need to meet the requirements that is set forth by the state. What's interesting with 3D printing is we literally have a wall that's made up of an outer layer and an inner layer tied together by a series of reinforcing, and we fill the void with a it's called a menoplast foam, which is it's a injectable foam, but it doesn't expand like most people think foams expand. It kind of just sits in the wall, but it fills every void, every nook and cranny, and it gives us a really, really good insulator. So it acts as a draft stop, as an insulator, a sound deadener. So you can't do that with a wood or a steel wall because you've got studs that connect inside to outside every 16 or 24 inches. This is a wall that doesn't connect, other than the fact of a series of smaller pieces of reinforcing, which really kind of assist in the idea of a thermal break, right? Breaking the interior and exterior and interior of the wall, so you don't get that thermal transmission in or out, depending on what season we're in. So that's unique. You could build 2 stud walls. That's really expensive.
Well, that's the thing.
And time consuming.
So people understand the limitation is when you have a 2x4, and the reason why people use 2x4 is it was the most cost effective way to build houses.
Right.
Although nothing's cost effective anymore right now. Literally, my construction costs are going up like 15% a year. And it doesn't matter if wood comes down, something else is going up. But the limitation as far as insulating an R value and how energy efficient the house is basically the thickness of that, the depth of the 2x4. Because you can only fill that wall with so much insulation. The cool thing about 3D printing, and I'll have the guys put in a little picture of the printer in the wall right behind me as I'm talking about this, is essentially you can make the void between the inner and the outer wall whatever you want it to be.
Right. So
you have one bead, and it doesn't increase your cost. It increases your cost slightly in the sense that you'll have more spray foam insulation to fill that cavity with. But I mean, is it possible if you wanted to go crazy and get an R100 wall, could you do it?
You could do that. Yeah.
You could do that.
Yes.
So there's no limit there. And again, the cost isn't that much more.
It's incremental based on, because the cost is the insulation, the men, and the equipment on site, right? Once you're adding additional insulation, it's just the material cost itself. Right. The labor's already there. So it's really, it opens up when you want to do something like if you wanted to do a massing wall, you could even increase the thickness of the print, right? To absorb more heat, let's say, on the south side of a structure that you could then take and utilize to heat the house. Where you, in order to do that, you would need to change the wall thickness, change the parameters, change the nailing pattern. With 3D printer, you just change the nozzle.
Exactly.
So it's just, once again, and that flexibility on site, you don't have to stop everything for 3 or 4 days or 3 or 4 weeks to redo and get approvals. And you just basically, you make the change because you understand what the parameters and ramifications are.
Yeah. So I want the second biggest question we always get is related to cost. And I never address questions people one-on-one with cost, because cost is obviously also directly related to where you are in the world or where you are in the country. We're in New York, which is one of the most expensive places in the country.
Yes.
So, this saves a ton of money. But in general, I want people to understand how the cost savings happens, especially as we refine the process more and more, which is what we're doing right now.
Right.
So, for example, like you touched on it before, what are all the things that you don't have in a 3D printed house that you'd have to purchase and install in a traditional? So
what's interesting is if anybody who's listening has ever driven past or lived next to a standard construction site, you've got generators running basically, 12 hours a day. You've got material dumps of 2x4s, 2x6s, lumber, roof trusses, insulation, all these things that are continual that don't occur. Okay, so you don't have a framing crew using nail guns for 30 or 40 days to frame the house. Okay, if we're using roof trusses, the trusses will be delivered one day, they're up in 2 days, and then start roofing. So that's not going to change. But you're eliminating all of that labor, that noise, the delivery trucks. It minimizes the carbon footprint of the project overall, because you're not running 3 or 4 different suppliers, bringing 3 or 4 different types of materials to the job site. You have one piece of equipment with 1 or 2 men, monitoring what's going on.
Yep.
And that's it.
Yeah.
So when you think about it, I think we identified 21 different, I wouldn't call them trades, but 21 different things that have to happen on a job site that you don't have to do if you're 3D printing.
Yeah, I mean, so the one that we're completing right now in Islandia, it is basically, we use a roof truss system, but it is 3D printed in its raw form. So we kept that line look on the interior and exterior, which I happen to really love.
Mm-hmm.
But when you look at the outside, you're thinking there's no siding, right? There's no foam board insulation on the outside for the siding. There's no, J channel. There's no nails. There's no Tyvek. There's no strapping. And then when you go inside, there's no sheetrocking. We even came up with a way on the floors where we're 3D printing the slab. Mm-hmm. So the last 2 inches, we're using like a self leveler.
Okay.
And then we're polishing the floors with like a diamond tip pad, and we're turning them into polished concrete floors. The idea as we go through this process to refine it, our next thing is we're going to be taking out the molding around the doors, because we're going to be using barn doors. So this way we don't have to frame out the openings. We don't have to trim them and make sure they're perfect.
Right.
The idea is to kind of bring an industrial look, which people in Brooklyn, like there's developers that pay big money for old buildings to have this kind of industrial look, industrial meets suburban type of look. And that's what we're building at a fraction of the cost and far less time.
Yeah, and it's also what people get used to. So what they're used to, when Levitt built Levittown, you had 3 models or 4 models. You didn't get to choose your door type. You didn't get to choose your trim type. You didn't get to choose. If that stuff's not available, okay, it just changes the kind of the dynamic of how the house works with the people who live there. Mm. And we've come to expect things like, if we want fancy molding, we want fancy molding. But that has nothing to do with keeping you warm, right? Yeah. Having a nice place to live. It's really more about how you feel about the place you're in. And as you mentioned, when you look at the idea of lofts with, minimalist finishes, it's actually pretty nice. It's less to take care of. Okay, it looks great.
Yeah.
It's easier to construct. It's just, the things that we currently have because when you buy a house in an existing development, you buy what's there. Mm-hmm. You don't come in and say, I don't like that trim. I don't like those windows. I don't like those doors. Mm-hmm. Most of us who grew up in the suburbs, didn't have the benefit of designing and building our own home to our specifications, right? So you get what you get. So I think that there's a certain segment of the market that will have no trouble with that because it makes life really simple, really easy, and that's just like what we get used to. I'm not a big trim guy. Mm-hmm. I'm just not a big trim guy. As an architect, I never was. I
like simple. Yeah,
modern stuff is fine because it addresses the way we live. Who sits in their house and looks up at the crown trim all day? I understand, but it's just one of those things. So I think that if we got, especially today, people, are doing so many more things with their lives than sitting and being concerned about what the inside or the outside of the house looks like. Mm-hmm. As long as it's aesthetically pleasing and it works within context of the neighborhood, it's not offensive. We're out, we're doing stuff. So I think it's less critical. Mm-hmm. And it's also more exciting because we then, we can use the material to its own benefit, okay, which is cleaner, simpler, and nicer.
So talk to, again, the design that you did for the first one was beautiful. It's an inline ranch type of setup. It looks like, a ton of other inline ranches, but just with like a cool edge, obviously, because it was 3D printed. Talk a little bit because again, people don't really understand. So if you're talking to building departments across the country, if you're talking to contractors or homeowners or developers or people that would like to use the technology but are saying to themselves, how good is it? How dependable is it? As far as concrete, mm-hmm. What do you say to them?
It's a superior system. So once again, the idea of using wood is because we've had wood, and wood was the least expensive, the quickest, easy to ship by rail when they had to get to places. If you look at Europe, Europe ran out of wood hundreds of years ago. So almost all the construction everywhere in Europe winds up being concrete, even if it's a single family dwelling. So that in itself says a lot to, you use the material that's best suited for you. And I think that, we have issues with concrete and carbon footprint, but we're not getting our concrete from concrete plants,
Yeah.
and shipping to the site in these huge trucks. It's typically proprietary at the site.
Yeah.
So it just concrete. If you think about permanence, it's concrete. If you look at municipal buildings, they're made out of concrete. If
Yeah.
you look at schools, they're made out of concrete. If you look at anything that the public finances, right, it's made out of concrete because the public doesn't want to have to keep repaying for buildings over time.
Yeah.
So historically, we have these really great, if you look at early American 1700s when the country first became developed, we built things out of wood because there was no concrete here,
Yeah.
right? We cut down trees, built houses. There's some terrific examples of early colonial houses up and down the Mid-Atlantic and in the Northeast. But if also look at the stuff that was built up in Newport, Rhode Island, that was concrete or concrete block or brick.
Yeah.
So certainly from a permanent standpoint, we like a material that doesn't rot because we have insects, doesn't burn because we have fire.
Yeah.
It's not susceptible to flood or high humidity. It's concrete is kind of the perfect material.
Yeah, I mean, I think concrete is probably next to water is probably the most tested material.
Without a doubt. And there are examples of, look at the viaducts and aqueducts in Rome that are thousands of years old made out of concrete.
Yeah, I mean, so people understand and I didn't even truly understand because, again, for someone to tell you they're 3D printing a house with a machine, you get it, but you don't really get it.
Right.
Even if you're someone that's built thousands of houses, you don't get it. You're like, they're building it in pieces and they're in a factory and they're bringing it over? No. There's a machine, a giant gantry type setup, like you were saying before, one of those little machines that 3D prints your phone case,
right?
But sitting on a lot, and it literally sits there and 3D prints from the footings all the way up to the walls. And pretty soon we're going to be doing roofs.
Yes.
So so this one has a roof truss system in Islandia, and we put the insulation, put the roof on, put all the windows on. I'm walking around in it the other day, and there's a busy road right there. A bomb could go off outside. You can't hear anything in this place. You hit the wall like these houses. I always joke around. I'm like, what's going to last longer, 42 Dean or the pyramids? These places are built. I mean, we're talking anything from 8,000 to 9,000 psi concrete. So people understand, and correct me if I'm wrong, that is what they're building skyscrapers out of.
Yeah, once you get above 4,000 psi, it's the standard. Your house foundation is anywhere between 2,800 and 3,500 psi.
Mm-hmm.
So when you talk about double that strength, it's unheard of because in residential construction there's no code requirement saying you have to use that strength of concrete. So this is kind of going above and beyond what's required because keeping in mind that the code is minimum, right? Code is the minimum requirement.
Mm-hmm.
So anytime that we can go beyond that, it's a benefit to the owner and to society as a whole because those homes, there is a portion of the code about that talks about property upkeep and maintenance.
Yeah.
So even from that standpoint, no peely paint. As the concrete ages, it just might change color a little bit, get a little darker, but that's it. There's nothing else that has to be done to it. No sealers, and certainly if you want to change the color, you would paint it, but then you'd have to maintain that. But the idea of it kind of changes the way you live with your house.
Yeah, the cool thing about technology like this is it's extremely versatile. So you can do a high-end minimalist type of design. Yep. Like I was going to build one out in Bridgehampton before the market in the Hamptons just decided to go to hell. So I sold that and moved on. But on the other end of the spectrum, you can do, amazing for affordable housing.
Yes.
Because you don't have to, you can cut costs so significantly. And then everything in between. The cost really depends on what you want your finishes to look like and how crazy you want to go inside. But so people understand, it can look exactly like a traditional house with sheetrock, or you can just leave it the way it is. I'm curious to know, because obviously you're a creative person, you're a designer. How excited are you from a design standpoint? Because the machine has no limitations.
Right.
Curved walls, like whatever your mind can dream up, you can print.
It's a little bit of a frustration, right? Because we have to make sure that, for example, right now, so we print walls, we have roof trusses. I just can't wait to be I can get that roof to come out, kind of print up.
Yeah.
And they do print. You can print flat and stand, right? So and we've done that for years, tilt up construction. But I really want to be able to print the entire thing from the ground up, right? And that's an issue relative to material. Setup strength, how fast is it going to dry? Yeah. And the limitations of the machine. So we can design anything. The idea is to try and make the best use of the material through the design. And it's exciting. It's going to be a challenge. And we're already playing with stuff like that. You see things that look like, like honeybee, honeycomb things, and which is great. But that's we know we can do that, right? Because the igloos have been around forever. So what can we do that nobody thinks we can do?
Yeah.
And that's really kind of the challenge. And then from our standpoint as architects, how can we make these structures really enhance the quality of your everyday life, right? How can, Winston Churchill said something about, we form buildings and after that they form us. Mm. That's why I'm an architect. When you're in the space, how is it beneficial to you? How does it make you feel? How does it make you think? How does it enhance the quality of your life? So we talk about it from the simplest terms, these concrete structures, but they're really going to be homes, right? And the idea is that because the material is limitless, how do we design a limitless house? Yeah. Right. And you come home every day to a limitless house that has all the stuff that you could never dream of, but you get. Yeah. You get it in weeks, not years.
Yeah, and with that, we're looking at the different type of smart technology. Like Atlandy is getting solar panels. It's getting a water collection system that irrigates the lawn.
Right.
We're looking into obviously doing radiant heat and different gray water systems. The coolest part is like when you're going to buy one of these houses, you can design it in virtual reality.
Right.
Did you sit and do the virtual reality thing?
Yeah, we actually have, we're doing VR for our clients.
Okay.
So, we can look at any project, anything that's in development and put you in the room.
That's amazing.
And have you walk through and, touch the table, touch the windows. I mean, they're not real, but it's another thing that when somebody has difficulty visualizing something.
Yes.
Put the goggles on and you can see out the window down whatever road you want the house to be on.
Yeah.
It's actually pretty cool.
When they put those goggles on me, I'm like, oh, when this becomes mainstream, like no one's going to want to live in the real world.
That's right.
Like you can literally have anything you want in life. It's crazy. So we've been talking a lot about residential houses specifically. I want to shift a little bit and talk about commercial construction, how this is going to impact that. We've been having conversations with big developers for industrial projects. This is the second industrial revolution, right? Industrial is popping up all over the place, huge demand, trend, society. COVID changed everything, although it was changing before, but COVID really, pressed the gas on that. Talk a little bit about, because I know a lot of people are doing tilt up and they're doing that prefab concrete. Now imagine, talk about a little bit the difference between having 150,000 square foot facility with 4 printers, 1 on each wall, printing this building in 30 days.
Yeah, because right now our biggest issue with those types of buildings is obviously the supply chain issues.
Yeah.
But when you're talking about even a steel prefab building, which has always been kind of the simplest and quickest way of putting up a large structure, it's no longer simple and quick because of coordination and issues with availability of steel, and also having people capable of erecting these things.
Yeah.
So when you think about 100,000 or 200,000 square foot facility, you need multiple cranes to set the steel. You've got crazy amounts of foundations, to kind of withstand that roof thrust when those walls want to move out. So 3D printing eliminates all of that.
Yeah.
Because we can actually design the wall to accept the thrust from the roof, through the foundation. It once again simplifies the job site. So from a safety standpoint, you don't have cranes and huge pieces of steel swinging around with guys literally up 30, 40, 50 feet in the air, fabricating and bolting things together. You've got 3D printed, and we can figure out the roof system. It's even better.
Yeah.
But you can 3D print, get up there. We can lay out deck, print the roof.
Yep.
And what I'm hoping is we get a proprietary mix that the print is the roof. So roofing manufacturers won't be happy, but there won't be anybody up on the roof after it's printed because it'll effectively be a membrane roof as printed. Yeah. So the idea of simplifying, once again, it's going to eliminate a lot of labor, but really these sites are dangerous sites. It's going to really increase the level of safety on these sites.
Yeah.
And put the buildings up instead of waiting 3 or 4 years for approvals. We can get these things hopefully approved in 2 years and built in 6 months.
Yeah.
So once again, limitless in terms of what we can do.
Yeah, and and I think what a lot of people. I get a lot of lashback on social media for people saying, you're going to be taking jobs, you're going to be taking jobs, you're going to be taking jobs. I think what the general public doesn't understand is there's not enough people to do this type of work.
Yeah, and not only are there not enough people, but for anybody who's in the trades over the past 15 or 20 years, we've lost a significant amount of people with the right abilities.
Yeah.
So when you get people who aren't trained properly, you increase, construction's an inherently dangerous business, as you know. People get hurt every day. So if you can't train people properly, if you don't have the proper people coming up through the system as apprentices, it cripples the industry.
Yep.
And literally that's what we're seeing now in terms of the labor shortage. We can't get projects done because we can't get people to work on the projects.
Yeah.
So if you look at the home building industry, analogous to the car industry, okay, there are still people that work in automotive unions. They're now high tech, right? They have degrees in computer programming, they have degrees in industrial technology, and they're running the machines that do the building. They're not banging out a fender over a mold, okay, like they did in the 20s and 30s. They're programming a machine that actually pops the fenders out, okay, or the robots that do the welding. And the housing and the construction industry will be no different. There'll be plenty of jobs once we make the switch to the maintenance of the machines, the programming of the machines, the construction of the machines.
Yep.
And then effectively, once we can get our act together on site, there'll be more people doing site safety, okay, and supervision, and less people doing the actual labor, because that's an industrialized society. The idea is to eliminate the labor, right? Even though it really didn't work for us, we're working just as hard, right?
Yes.
But that's the idea. So I don't see an issue. You're right. Will the unions be upset? Absolutely. Will the wood lobbyists be upset? Absolutely. They'll find a different way to go, right? So we won't be milling trees for 2x4s, we're milling trees for interior furniture. Okay, we're milling trees for other things. This is. I think it's almost critical for the industry, because you've seen what's happened during the pandemic, specifically with material availability and the labor shortage. You can't buy a car because your computer chip won't come from Taiwan. That's what we're looking at, the same thing. We can't build buildings because we can't get the material, we can't get the labor. This basically eliminates that, allows us to do what we need to do. I mean, there's demographically tens of thousands of houses and rental units that we can't build, right, that are needed right now.
For a number of different reasons. Like myself as a home builder, you have a market that's dropping, but you still have limited supply, and you have the cost to build going up exponentially. Right. Even in this market, you're squishing. There's nothing in the middle, which makes it virtually impossible for someone like myself to build houses. And that's why we're somewhere between, depending on who you talk to, 3 to 5 million houses light across the country.
Right. And you see that in the for younger kids. I have 4 children in that age bracket. Rents are crazy. Housing prices are crazy. Yeah. So it really limits your ability to, because salaries have not kept pace with inflation. Never mind with housing costs. This is the answer to that, because it effectively provides those units for people that need to be living. Forget about the things like homeless tents in Manhattan or New York City. You can erect very quickly quality housing for people that don't have it available to them ever. Okay, at a fraction of the cost that we're currently doing right now. So once again, it's such an, especially when you look at the way society is now, it's such an exciting way to be able to take care of pretty much almost every segment of society without really seriously. It doesn't exist yet, right? Except in small pieces. So when you think about how you can scale this up to solve all those issues, like what are we waiting for?
Yeah, I mean, I think the biggest thing is, and you deal with it with the towns, with development all the time, it's in general human nature, people fear change.
Right.
But as soon as they realize it and they adopt it, it spreads like wildfire. But I want people to imagine for a second, 20 years from now, you go into a real estate office, you sit down, you put 3D goggles on, all of a sudden you're in the street, in the street that you're going to live in, and you're walking into your house and you're sitting down on the couch and you're customizing the colors, the square footage, even down to the furniture that you're going to buy.
Right.
And then 3 months later, you come back and a machine had basically 3D printed everything.
Right.
So I want to close out kind of talking about, the future and all the exciting things that could happen with the technology, as far as, the use of glass, like we were talking about before, as far as, using recycled plastics and 3D printing interiors. Where could this go in the commercial and residential space over the next 20 plus years?
I look at, you look at things like, we're printing, walls, right? Next is going to be printing roofs. Next to be printing complete building envelopes. Okay, why can't we print a bathtub, right? Why can't we print a vanity, a toilet bowl, We can certainly, if everybody's ever gone to a factory, like for example, Kohler, where they make toilets, right? Cast iron tubs. There are guys that work in the shop and they're literally, these are clay, they're vitreous china, so it's clay, and they form them, they pop out of a mold, and the guy kind of shaves a little bit. So they're really doing it exactly the same way it's been done for hundreds of years. Yeah. So why can't the bathroom, the county requires us to have everything in the bathroom sanitary, which means you have to have an impermeable floor, you have to have, a tile surround your tub. That whole area can be printed out of a material, right? Impervious, the color of your choice, seamless. Yeah. That you can literally go in there with a hose, rinse it down once a week, and call it a day. Yep. Now, granted, people like fancy tile. That's kind of the next step. But I envision you could literally print every single thing in the house. Yeah. Including the windows. Okay. If you look at a typical vinyl window, once again, it's limitless.
Yeah, and a big thing, obviously, landfills, the amount of waste that we produce as a society. Imagine taking glass and turning it into a fine sand that can be used in place of sand. Imagine taking bottles and recycling them and melting them down and printing doors and moldings and tubs and toilets and all that.
You could have a house that's rated at like 75% post-consumer material. Yeah, which is actually pretty cool. Yeah, so.
It's it's a very exciting time to be in construction. I'm blessed to know you. I'm blessed to know Enzo. I'm really excited for what the next 3 to 5 years is going to bring. Like we were talking offline, and you said perfectly, so eloquently, this is the iPhone in construction.
Yeah. Except it's going to actually enhance our lives.
Yes. Okay. Yeah, my thumb hurts a lot now. I'm really worried about later on the possibility for arthritis, but you're right. Mr. Paul, you're a gentleman. Thank you very much for what you're doing for us, for the industry. Thank you very much for coming and speaking to everybody. Thanks. Your wealth of knowledge. H2M, amazing architecture firm. You guys do a whole bunch of large projects for me, assisted living. I mean, you guys just tell a little bit about what you guys do so people know.
H2M does everything. H2M has every discipline in-house. So from insurance, environmental, site civil, survey, mechanical, electrical, plumbing, structural, architectural. Anything that's involved with the construction industry, we actually do in-house. We do a lot. We build communities is kind of one of our taglines, because we do. So anything you can imagine from the ground up, we've been involved with. We're very good at it. We've been doing it. It's going to be almost 90 years coming up. So very exciting place to work. Very involved in the community. We do a lot of give back stuff. The community. We actually look at that's why I'm so excited about some of the potential, habitat houses, 3D printed habitat houses, 3D printed storm repair work, storm mitigation work. It's and we're excited to be on the forefront of this. And we appreciate our collaboration and cooperation.
Absolutely.
I'm just really looking forward to moving ahead as rapidly as we print, right?
So if anybody out there is interested in 3D printed construction on the architecture side, obviously reach out to H2M and Mr. Paul. If anybody's interested in consulting or development, myself, Charles Weinraub, Printed Places, check us out on Instagram, TikTok, Twitter, printedplaces.com. That's a wrap.